think I'm just going to dive right in. At the Human Computation Institute, our mission is to combine the complementary strengths of humans and machines to solve problems that can't be solved by humans alone or by machines alone. And of course, we do this through, among other things, through the modality of citizen science. So if you consider the human brain, possibly the most complex information processor in the known universe, it is a massive predictive engine and extremely efficient. So supercomputers with equivalent processing power require 20 megawatts of power. The human brain does the same amount of computation with only 20 watts of power. So a marvel evolution. And the human brain is so sophisticated that as a neural network, it can actually do some symbolic processing, which gave us the ability to have language. But when it comes to anything sort of more complicated in terms of logic or arithmetic, the human brain doesn't do as well. And so that's why we created computing machines in the first place. So the calculator built in the 1950s or 60s could do simple arithmetic, multiply two large numbers together much faster than any human, and it's still faster than any human today. And of course, machines have evolved a bit since then, and they're good at remembering things and following a process, executing software code, and then doing logical reasoning. So you can imagine there's kind of this AI timeline where as machines and AI technology becomes increasingly advanced, it becomes more human-like in its ability. So what I'd like to do is just begin by talking about what I would call the old AI. So this is kind of pre-ChatGPT. So I'm going to kind of pause the line right between visual perception and linguistic ability. We had natural language processing, but not like what we have today. So this is what I mean by old AI. So what have we done with old AI? So we have, Janice Dickinson and I published a paper in Science in 2016 describing a few different frameworks by which we have a machine that's mediating a kind of a workflow to enable human collaboration that couldn't happen otherwise. And so the first kind of version of this, the first framework I want to mention is something that's probably very familiar to you, called microtasking. Basic idea is you have a computer that has a large volume of data that needs to be analyzed. There are barriers to doing the analysis using machines only, so the computer takes little pieces of the data, sends each out to a different human, the human responds, and then sends the data back. And the computer is sort of a clearinghouse, and then it combines all the individual answers into a final analyzed data set. So we do a version of this with our Saw Catchers project, which Rosie mentioned, and this has been going on for about 9 years now. We just had a 9-year anniversary in October. And so the basic idea here is that people who are participating are looking at blood vessels in a mouse brain, and they're trying to make a simple determination. Is blood flowing through that blood vessel, or is it stalled? And this helps advance Alzheimer's research at Cornell University. And so today we have over 140,000 citizen science volunteers who have registered and played Saw Catchers. On any given day, you might find about 100 people participating. And because of this, we're accomplishing Cornell's research about 5 times faster, which makes it possible to answer research questions in only a month or two, whereas previously it would take them 6 months to a year just to answer a simple research question. So part of what makes this possible is we appeal to this wisdom of crowds phenomenon. The idea here is that because no two people think in exactly the same way, if you have many people, for example, in Saw Catchers looking at the same blood vessel and answering, is it flowing or stalled, they might not all answer the same way, but on average, their answer is better than any individual answer. And of course we had to validate this, and the Cornell collaborator said, we need to have at least 95% accuracy to make this work. So he said, okay, we'll show the same blood vessel to 5 people. We'll show it to 10 people, to 15 people, to 20 people, and averaged their answers. And it was only when we got up to 20 people answering about the same blood vessel that we were able to achieve the target accuracy. But this was very inefficient. We realized it was enough to say, okay, we have a basis in confidence to launch the project, but over time, we optimized our methods, and today, on average, 4.5 people look at a single vessel. Stalk Catchers has analyzed over 20 data sets. The research results have been published in top-tier journals, and when they allow us to do it, we acknowledge the citizen participants, and we even hyperlink to a list of the usernames of the people. So after about 4 or 5 years, we had amassed millions of annotations, and so we ran a machine learning challenge to see if we could use all the human-generated annotations to train a machine learner to do the same job as stalk catchers. And what we found was that the best models could achieve about 92% accuracy. Not quite good enough, but still very good. And so we were curious, is there some way we could use these to help with the analysis? And so if you remember, with the wisdom of crowds, it relies heavily on this diversity of perspectives. So one way we measure diversity in stalk catchers is response bias. Response bias, in this case, is the tendency for somebody who's looking at a blood vessel and they really can't decide whether it's flowing or stalled, to err on the side of flowing or err on the side of stalled. And so the blue bars represent the distribution of human bias in stalk catchers. And when we looked at the 100 machine learning models that came out of the challenge, we saw a very similar distribution. And we were curious if that represented true underlying diversity of perspective. So we looked at the top 3 models and we saw that they were fundamentally very different in many aspects of how they were created and how they worked. And so we decided to run an experiment. And we said, why don't we replace some of the humans in stalk catchers with bots? So we created bots out of these machine learning models. And so we called them crowd bots, and we gave them agency and allowed them to play stalk catchers. And in fact, they would show up on the leaderboards. And we actually had to put in a speed limiter because our participants were getting upset that they were rising to the top of the leaderboard, because while everyone else was sleeping, the bots were running all night. But you can see that Gaia, Laura Onak's bot, was in 3rd place. So in the end, we discovered something interesting, which is that if you looked at groups of humans and applied wisdom of crowds to a group of humans, you got a better answer than all 3 bots working together. But when you looked at hybrid cohorts where you had humans and bots answering about the same vessel, we got an even better answer, suggesting there was a new kind of complementarity, a new kind of diversity of perspectives that was actually beneficial. So that's some of the work we've done in microcasting, and then just to sort of cover these other frameworks, one of the other approaches that we've taken is using workflows. So this is where people can engage in different ways with an analysis. And so the machine would assign one task to a person, take the output of that, send that to another person, have them do something different to that, maybe make some decisions along the way, do some sort of a decision tree, and then ultimately come up with the results. So it's sort of a more sophisticated workflow, but you still have humans in the loop. So just a quick example of this is the San Jose Budget Games. This is for 2009, actually, so pretty pioneering work. There were no computers actually in this room. They got about 100 citizens from the city of San Jose, in California, and they put them around tables. Each table had a moderator, and they gave each person a portion of the city's budget to invest in different ideas as a way to kind of do a voting exercise. And then the moderator would collect all the votes from a table, and then they would all get coalesced together into a final policy recommendation. And then the policymakers would sort of act as an electoral college and then actually invest in those policies. And that that way. So then they realized we can scale this. If we instead of having to bring a bunch of people into a room, we could have 1,000 people do this if we just put it online. So what they did is they basically replaced the moderators with a machine-based process, and they encoded the workflow on the machine, and they were able to actually have a very successful project doing that. So finally, we have problem solving. And I'm not trying to say this is a complete or exhaustive set of frameworks, but these are the ones that, that I'm familiar with. So in a problem solving ecosystem, then it's a bit more organic. So it's less of a pre-specified workflow, and people can kind of engage as they will in different aspects of a collaborative kind of system. And one example of this, and probably the most famous example, is Wikipedia, where you have collaborative document generation. And people can write, they can edit, they can delete, and so on. Just to give you an idea, it's kind of a hybrid model because it is this collaboration ecosystem, but within each specific kind of task, there's this very complex workflow where people can be involved. This is just the process for deleting an article from Wikipedia, to give you an idea. Okay, so that's what we've been doing. Now, suddenly, transformer models, right? I'm sure this is a familiar sight to some of you by now. And by the way, no matter what you say, I'm going to tell you you're absolutely right. So ChatGPT is a pretty remarkable thing. It's taking medical exams better than medical students can. And I have a friend who says that if we just give ChatGPT more training data, more CPUs, and a bigger context window, we're going to exceed human intelligence. So I'm not sure. I wasn't sure, and I thought, you know, I want to kind of, my instinct was no, but I didn't have a real strong basis for arguing with him. So I decided to look into it. So I started to explore differences between how ChatGPT thinks and how humans think. And so I discovered that there are a few key gaps. So if you study this photo, you may feel disturbed by it. So you can imagine that a girl has an experience seeing her grandmother, she journals about it, and then she decides to encode that and generate an image of her grandmother. And of course, there's something not quite right about that image. Why does this happen? Because ChatGPT doesn't have a working model of human anatomy. So it's basically trained on pixels and it generates pixels. So in this case, ChatGPT is producing something that is consistent with what was written, but something that any human would realize isn't something that would happen in reality based on our lived experience. Another gap is about causal reasoning. So I did an experiment. I said, hey ChatGPT, I want to save water. I put a rain sensor in the middle of my yard, and it turns the sprinkler off when it gets wet. So if I live in Phoenix, Arizona, how much water can I save by having this rain sensor there? And so ChatGPT did a nice analysis, you know, and it said, okay, in the end, you can save about an entire swimming pool's worth of water over the summer by installing this rain sensor. But what ChatGPT missed in this case is that when the sprinkler goes off, when the sprinkler turns on, then it rains on the sensor, and then the sensor turns the sprinkler off. So there's this kind of feedback. So there's this gap in causal reasoning here. And then my grass dies. Oh no. So in this case, you know, the sort of the linguistic pattern matching, you know, it's trying to solve one kind of problem and missing a bigger picture, which is a context. There's also this aspect of active abstraction. So I did another experiment, and I said, okay, I'm kind of an astronomy buff. I'm not good at it, but I enjoy I geek out on astronomy. So I said, please cluster the 20 brightest stars by proximity to each other. And ChatGPT said, yeah, perfect, I'll do that for you. And then, you know, we can see constellations from this and so on. So this is what it produced. I said, no, this is not what I was asking. I want them by their actual proximity. So ChatGPT, based on all of its training data, which was predominantly about apparent proximity of stars, gave me an answer based on that, instead of recognizing that what I was really asking for was the actual absolute distance in space. So once I clarified, then it gave me the answer I was looking for, and it showed me in 3D. But it will assume this, and it won't shift context unless you prompt it to do that. So then there's this aspect of episodic memory. I don't know if you've ever encountered this kind of a thing. So I said, hey, I'm going to be taking an overnight flight. You know, I've packed, these are the things I've packed: my charger, my passport, my Warframe tablets, noise canceling headphones. I tell you, I really love noise canceling headphones. You know, noisy airports. Is there anything else I should bring? And it says, you know, it's a decent list. You might also consider these other things. You know, I don't know. Does anybody actually use compression socks when they travel? I don't know. Maybe it's a good idea. So then later that day, I came back and I said, you know, I've got a pretty bad headache. How much ibuprofen should I take? Oh, you know, here's the typical dose you could take, and have some food with this so you don't get an upset stomach. So there's a problem here, which is that I'm taking Warfarin, which is blood thinner, and if I take ibuprofen, that's a serious problem. That's a serious risk for bleeding. But again, well, in this case, it's this aspect of not really tracking sort of, you know, what was said earlier and sort of a progression over time. And then the fifth gap that I identified, I would call metacognition. So the idea here is, or the example is about vibe coding. Have you heard of this? Maybe you've done it yourselves, where you can write software code without being a software engineer. So you just describe to the AI, hey, I want software that does this, you know, write it for me, or tell me how to write it. So I've actually done this, and it's an exercise in frustration for me, to be honest. So I said, hey, let's write this code, and then it'll give me the code, and then I go put it in, and I run it, and then I get an error, and I come back, and it says, oh, you should make this change. Okay, I make the change. So, and we keep iterating this way until we finally get to something that kind of works. So as an example, and I've actually had something very similar to this happen to me, you say, hey, I want a link that goes back to my homepage. Can you give me some code to do that? So it gives me some code. I go put it back in the server, and I test it out. I go and open the web page, and I get this very vague HTTP 500 error, which basically means nothing except that your website isn't working. So I go back, and I tell ChatGPT, HTTP 500. And it says, oh, you should check, you know, the web server configuration file. Well, there's a problem here. You gave me a line of code. That's the only thing that's changed. We didn't change the configuration file at all. So you're not thinking about your own thinking. It's like you can't access the thing that just happened that you just suggested that I do. My answer to this question that my friend raised is, yeah, I don't think scaling is going to solve all these issues. It's going to make it faster. You know, it might do better predictions, but these are qualitative differences, not quantitative differences between AI and humans. So, considering what ChatGPT can do and what it can't do, and what we've already been able to do, I kind of put together this list of a new complementarity. So this is the list that I keep in mind as I think about what can we do now. AI can do some new things, but let's not overestimate what it can do. And so with that in mind, I want to tell you about this workshop that I attended in April. So this was the Computing Research Association. And this was kind of the follow-on workshop of a workshop that I organized in 2014 for the Human Computation Summit. And a lot of the same people attended here, and you might recognize some people. This is Carrie Seltzer from iNaturalist, and then We have Laura Truey and Lucy Fortson from Sooniverse, and some weird guy standing around. And so we were trying to figure out what can we do with new technology, new AI for citizen science. And the kind of resounding theme was this idea of the adaptability of AI, that we can use AI to sort of tailor the participants' experience based on their own needs, their own strengths, and the changing context. So I'm just going to list, we had a laundry list of these things, but these were the ones that stood out for me, some key tensions that emerged. So one was this idea of broadening access versus systemic inclusion. So we have an opportunity here now to include people that otherwise might have felt like they couldn't be included in citizen science by using AI to reach them in new ways. I'll go through these a little more in a second. Privacy preserving versus research values. So we can use AI actually to help people preserve their privacy while retaining the research value. And then this idea of adaptive dialogues. So here, I mean, the basic idea for broadening access is just that precision AI, lowers these structural and cognitive barriers, and rather than kind of reinforcing existing norms. And so in stall catchers, actually sort of, with the old AI, we had a version of this. We have the sensitivity bar, so we kind of measure in near real time how a person is doing, how sensitive they are to the classification, and this bar can drop if you start to make mistakes, like this. So this is actually a way to increase inclusivity in the sense that we have folks with early stages of Alzheimer's disease contributing to experience sundown in the afternoon, which is a cognitive slump. And so by measuring sensitivity in real time, we can adjust how much weight we assign to their answers. And then everyone, I have a cognitive slump in the afternoon. I don't have coffee, I can't really think. So this allows people to participate without worrying that they're not research data in any way. And then we ran a study with Microsoft Research on human AI partnerships where we gave a little bot that would make a suggestion to a person. The bot was not perfect. And what we found was that humans could learn when to trust the bot and when not to trust the bot. And when they had complementary biases, they would actually perform better than the human learner bot learner, which was consistent with our CrowdBots study. So then, this other kind of point of tension was between privacy and research value. And so, a lot of people worry about, all my clinical data is in a database, or some aspect of my health data is in a database, and now researchers are going to use it. And I'm not sure I'm comfortable with people knowing all these things about me. So you can build an API in front of the database that mediates the communication between researchers and the database. And so what we can do is we can use AI to allow people who are contributing their own health data to actually specify, this is my comfort level. This is how much granularity I want to allow the researchers to see, or I'm only comfortable with my data being used in the aggregate, for example. And then these individual preferences can actually be governed using the API layer. And then another idea that came up at the workshop was about an adaptive dialogue. So the idea that instead of just giving rote feedback, you can have feedback that's sort of tailored to the individual. You can engage in a dialogue with the person who's participating. So there's this famous example in Galaxy Zoo, the Green Pea Galaxy Discovery, that I'm sure you've all, or many of you have heard by now. So in Galaxy Zoo, you're trying to classify galaxies from the Deep Sky Survey. Is it a spiral galaxy? Is it a barred galaxy? So you do this classification. Volunteers found a galaxy that they couldn't classify given the options that were provided to them. So they went off on their own, and over a long period of time, they kind of self-organized, and they did the research, and they came back and they said, hey, we think we've actually discovered a new kind of galaxy. And the experts said, yeah, you're right, you did discover a new galaxy. But it was a difficult and extended process. So what if somebody sees something anomalous and they could just engage in a dialogue with the AI. And Chris Lintott from Zooniverse was at the workshop, and he said, this would be fantastic. We could probably have made many more discoveries if we implemented something like this. We're in time. Doing okay? So keeping in mind these kinds of observations and the new AI capabilities, I thought I'd just describe a few projects that we're working on at the Human Computation Institute and how we're incorporating AI into those projects. So, Soft Catches, which you've heard of by now. That's just an opportunity to use this kind of adaptive dialogue. So, right now, if you make a mistake, we just say, sorry, you guessed wrong, or you made the wrong classification. And this can be discouraging for people. We have seen in focus groups, people get kind of discouraged, and we have to give them the encouragement. But the AI could do that. The AI could actually engage in a kind of dialogue and say, well, what made you think this was flowing? And then, oh, okay, well, as it turns out, what you thought was an indicator of flowing is actually an indicator of stall. Sort of explain it and do it in a friendly way and encouraging way. Another project that we haven't tried that yet. That's just an idea. But we have another project that we've just embarked on recently. And so there was this project in 2009 that was founded by Sir Tim Gowers from the UK. The idea was to do massively distributed mathematics. And he said, what if we use a wiki and a forum, and and we use a wiki and a forum, and we use that to kind of mediate collaboration among many different professional mathematicians. So we can all work on a problem together and use the internet to help us do that. And they actually were successful. They advanced existing theorem proofs, and they proved some new theorems taking this approach. Fast forward about 15 years, and a philanthropic organization called Renaissance Philosophy put out a solicitation called AI for Math Fund. And they said, how can we use new technology, new AI to help advance math? So of course our approach is, well, we're not just going to use the AI to do it, we want to use humans mixed with AI to do this. And we saw that with the original project, one of the big barriers to participation was that if you showed up and you saw a theorem that a bunch of professional mathematicians were working on and had been for a month, you had pages and pages of very dense material to sift through. We said, well, we can use AI to synthesize that. Have you ever given AI just like a 90-page article and said, hey, give me a one-paragraph summary? It's beautiful. You kind of get the cliff notes that way. So we said we could leverage that kind of capability here, and they did. You're probably wondering how that's there. So they did. They decided it was a good idea, and they gave us a grant to do this. So we're kind of 3 or 4 months into the project, and I thought I would show you some of our sausage making. This felt appropriate, just because we're in Switzerland, I'm eating a lot of sausage. Obviously, not very good for me. So we said, we don't just have to use a wiki and blog anymore. We can make a purpose-built interface that leverages AI to improve on collaboration opportunities. We really want to democratize math so even high school students can easily engage with this. So anyway, we had to come up with a way to sort of visualize evolving proofs, and then we wanted to come up with an interface. This is the sausage making from whiteboard to kind of wireframe, and the basic idea here, as you can see, is that you can have an active dialogue. The AI can be the mediator. So you show up and you say, hey, I want to help you prove a theorem. I don't know anything about theorems. And the AI can say, oh, let me give you some examples. Let me walk you through it. And you say, oh, okay, let's work on a real problem. So then you pick one, and you just, through the idea is actually to do everything through the medium of a conversation with the AI. But then, remember all those issues with causal reasoning and metacognition that ChatGPT has. So we have this other tool in our back pocket called a formal theorem prover. So once you get an idea, ChatGPT doesn't have, you don't have to trust ChatGPT. It sends it to the formal theorem prover, which is actually horrible at communicating with humans, but really good at telling you whether a theorem is valid or not. So this is our approach, and our engineering team is actually actively building this while we're here at the conference. So I can't wait to see what they've got when we get back. And so the last example I'll mention is related to how precision AI can help with precision medicine. So we have a project called the Open Body Initiative. We've socialized this in the Lourdes Foundation and had strong interest at a high level. We don't have a formal contract or anything yet, but we're excited about the idea of crowdsourcing a model of human physiology. So you have lots of organ models out there, you have lots of cellular models, models of all the different omics, what they call multi-omics. And so what if you could integrate them into a single working model? Because if you take a kidney model in isolation, you can sort of parameterize everything around the kidney, but that ignores all the feedback loops. If you start changing the kidney, it's going to change everything that's connected to the kidney and what's happening there. So our idea is, let's give people kind of a Wikipedia type environment, but instead of collaborative document writing, people can do collaborative modeling. They can take their own models and build them into the virtual human model. And so once you have such a model, you can just let AI loose on it and say, go play with this model, try different treatments. You're not going to hurt any people doing this. Maybe you'll discover something we haven't thought of. Obviously, we can then do preclinical research using this, and we can better sort of filter out problematic side effects. And we can create digital twins. So for people who are interested in quantified self and so on, you can take this virtual human and put it in your entire clinical history. The AI will then tailor the virtual human to your history, and then you can say, I want to see how this treatment would impact me specifically. So I guess to sum up, precision AI can enhance, I think, the kind of work we do in health-based citizen science by tuning to the interests of people, to adapting to individual needs and conditions, and better leveraging our more current understanding now of the respective strengths of humans and machines. Thank you very much.
Thank you. Thank you for your presentation, very inspiring. I work a lot around the data privacy, and I would like to ask you about the API layer, if you could maybe elaborate more about it, and also, because what I fear is that when you give these options, maybe you actually get the contra effect, that you even get less data. Yes. Yeah, I would like to hear your opinion about that.
Yeah, I think that's a great question. It's a double-edged sword. I agree. With the API, one of the things you can do is you can set it up so when a researcher comes to use the database, they can only get aggregate information. But ultimately what they get is averages. There's some measures of central tendency, distributions, this kind of thing. But there's also this issue of triangulation, where if you are clever and you ask enough different kind of aggregate questions about different conditions and things, if you were really trying hard to home in on a person's individual data, you could probably figure some things out. So I think that's where you want this aspect of continuity of experience, where if somebody's querying the database, you're tracking all the queries they've made so far, so you can be kind of intelligent about it that way. Obviously, a highly motivated person could log in as 10 different people and try to game the system. So I don't have all the answers, but I think you're asking the right question.
Me? Okay. Thank you. I will post my first Thursday. Okay, this should work. Accuracy is a big topic, and I didn't quite get an impression of how you work with accuracy in your different projects. And here I'm thinking of digital divide, that kind of problem or challenge.
I've got a whole project idea for that. During COVID, this was a problem is that they were doing online teaching, and then you had students in rural communities who didn't have internet access. This is the kind of thing you're talking about. Yeah. So I think this is a kind of an infrastructure problem, or it can be. In our own projects, I think we haven't really dealt specifically with that. I think one thing we've done is we've tried to reduce bandwidth requirements so people don't need a strong internet connection. We did an international catch-a-thon, and we wanted to have all 7 continents and the International Space Station participating. We didn't get the International Space Station or Antarctica, but the reason we didn't is because of the bandwidth requirements. Apparently they need it for life-preserving purposes. It's more important than saw catchers. But that was an incentive to kind of reduce those barriers. Yeah, thank you.
What's your project idea?
The idea was actually to use the Postal Service to carry data. So you've already got, at least in the US, we have mail trucks that come by your mailbox every day. So if you just take a magnet with some kind of transmitter, when they come by, everybody's got a way to pull the data and push the data. So you get kind of a data dump and a data push every time the mail truck comes by. That was the idea. Yes, sir.
Yeah, thank you, sir, for your presentation. So as you mentioned, we moved from old AI to the precision AI. So how do you see the use of or increased use of AI more in terms of the climate change and that impact on the human health?
Sorry, could you repeat the last part? How do I see
the more usage of AI and its impact on the climate change, because we use more data kind of thing, and it leads to some.
This is the water thing. Isn't like there's some equation about the amount of energy that's used, and it uses up water. And I've heard about this. I don't honestly fully understand it. It's about cooling the systems, maybe something like that. Well, so I think one answer to this is maybe a little off topic. Is I've seen that there's this kind of we have these very general purpose large language models, and so now they're training more specific versions that are purpose built for example, being on a smartphone, and they're building smaller versions of the GPUs to provide kind of resident computing. So you'll have a smartphone that has a mini GPU that's running a mini version of ChatGPT that's just perfectly built for, tracking your calendar for you and doing the kinds of things you do on your smartphone. I think, efforts like that to reduce, computational requirements can help. So instead of computing bigger, let's compute smarter. And I think human in the loop ideation, I think AI is actually a good tool for brainstorming. So it's not going to give you the best idea, but if you have some ideas, it can help you make them better. That's all I got. I think he was like 100 milliseconds faster than me.
It's run by AI. Thank you for this impressive overview you just gave. And I'm trying to catch up with all the little details that you've been telling about. And that's exactly where my question is about, because technology is speeding up so quickly that our minds, at least my mind, or my body-mind system, can't catch up with all of this. So I can see the steps you're developing, but what are the governance steps that go along with that allow us as humans to at least be in a kind of control of what's happening there instead of all outsourcing it to some big company who run the ChatGPT? So what's the matching line, so to say, of your progression?
I actually wrote a rap about this, but I'm not gonna. No, actually, I actually did. Because there was an NIH workshop in the U.S. and they said, give us a one-page slide, or you can sort of, sing us a song or something. So I won't put it. I won't show you, but for your sake. But if you're really curious, I think it's somewhere on our website. So we have a project for this, and the idea is to have a human computation system where you employ the machine to facilitate human governance of AI, which sounds scary. It's like we shouldn't have any machines involved in AI. We shouldn't have AI involved in AI governance. But I think one of the challenges is, I think, as you pointed out, that AI and emerging technologies in general are a moving target, and it's not just the technologies themselves, but it's new uses of existing technologies. If you look at an IRB and the kind of ethics that are built into human subjects review and the ethical boards we have today, they don't address a moving target when it comes to technology, nor do they address shifting values. So values change. Every person has a different set of values. Every community, every country, every family. So how do we come up with a set of values that can be used for AI governance that we all agree on? Well, we might not agree on all of them, but we have to come up with something that we generally agree on. And of course, wisdom of crowds, and the research around wisdom of crowds is trying to figure out how to come up with aggregates that are representative. So it's a big challenge to say, how do we aggregate human values, for this purpose of AI governance? And if you catch up with me later, I can give you a link to a paper we wrote about it. Did you?
So the important thing is that you recognize the issue. Anyway.
Okay. So the important thing is you recognize the issue there. That's the main thing. I'm happy that you already have part of the answer, so I'll catch up with you later. Thank you.
Sounds good. Thanks a lot. Actually, your turn.
Okay, thanks. I would like to look back a little bit to the broadening access and the systemic inclusion part, because I think particularly in health sciences and health-related citizen sciences is a huge thing. And my question would be that I like the direction we're going in with lowering bandwidth and but I think that only kind of covers the barriers to some extent. And I was wondering if there were any, speaking of project ideas, where you would define the project as more of a patient-driven question. So not so much kind of defined by science and then how do we get patients or how do we get citizens in, but more okay, what is it you guys want to find out that we can help you with?
I love that question. We have a project about that. We almost had a project about that. So there's a group called OIS, Open Information. This is in Vienna. Maybe you know Ben Misbach and Patrick, Rafaela, Kaiser. I don't know if any of you. So
I'm from Vienna.
You're familiar.
Yeah,
okay.
I work with Ben.
Oh, perfect. Oh, Ben.
That's the question, I guess.
Ben's amazing. So Ben and I were actually developing this idea together. We called it Me-Search instead of research. So the basic idea is that there's kind of, there are folksonomies and, there's personal experience and quantified self where people say, I've noticed whenever if I start to feel inflamed, I take a cold shower, I feel less inflamed, I feel better. But maybe there's no research paper, nobody's actually investigated this. Is it a placebo effect or is it a real effect? So how do you, as an individual who's not a scientist or a medical researcher, put that in front of somebody who might want to actually take it on and research it? And the problem is in science today, in academia, you have an advisor, they're following this research path, you're their student, you follow a branch off of that. So you get all these kinds of like rivers and tributaries and things, and there are these big research gaps in between that nobody's pursuing. So how do you get all the in-between stuff that real people care about in front of the researchers? So the idea was to kind of have a platform. If anybody wants to do this, either go for it or talk to me. I would still like to do this, but where you have kind of a social media platform where people are saying, hey, I had this experience, or I wonder if this is true, and then you have a way for people to upvote and downvote and bubble up and kind of like weed out the crazies, and sometimes the crazy's a good crazy, so you don't want to lose that one. And then, that's there for researchers to go and grab and evaluate, and then you of course have to build in the incentive structure for a researcher to take it on. Well, why would I as a researcher want to take on one of these problems? Well, because 50,000 people want me to, and if I publish results about this, I'm going to get really good media visibility. So you always got to think about, what's the win-win. Is that?
I think we have time for another couple of questions.
Hi, thank you for your talk. My name is Shamila, I'm from Brazil, and I have a very specific kind of question about inclusivity. Do you have any projects to which you include indigenous or First Nation people? I'm asking this because we are doing the first citizen science initiative in precision public health in Brazil, and we have this challenge of including digitally literate indigenous people because their voices are very important. So do you have any experience to that?
I wish I did. The only data point I have for that was from a different NIH workshop where the question of data bias came up. So, you build these machine learning models, then clinicians are using them to diagnose or come up with, help them make treatment decisions, except they're trained on data from a very narrow population. So the question was, where you have a much smaller sample with indigenous people sometimes, then you don't get enough representation in the data. So one strategy around that was to take, let's say you have data from 10 indigenous people, was to sort of trick the model by fabricating for each of those 10 people a kind of a virtual person who's a variant of that to give them more weight in the model. I think that was kind of what we came up with, but I don't know if that works. No.
Yeah, thank you so much for your really inspiring talk. I saw some examples there of direct interaction between citizens and the AI, and currently I'm engaged in a project where policymakers are actually having conversations with insights from interviews with citizens, and there we see that the boundary of recognizing and being aware that this AI that they're having a discussion with is sometimes very thin. And I was wondering if you have any experience with this type of awareness or these interfaces, and how you can, where you have insights about the ethics of this.
So I think I only heard part of it. Is the question about, so it sounded like you're talking about policymakers engaging with citizens, but sometimes there's an AI in between and they're not sure if it's an AI or a citizen, or the citizen doesn't know if it's an AI or a politician, or...
Yeah. Maybe I can say it like this? I don't
Yeah.
know where you can understand better. So, whenever someone is engaging with an AI...
Can you use the microphone?
Whenever someone is engaging with an AI, it can be the case that because it's so engaging, they don't notice anymore that it's an AI. They feel like they're talking to a real person. For example, if you have a chat in this interface, they think that there might be a real person behind it. So I'm wondering how you handle this in the projects that you have.
So I think the question is, in a citizen science project, is there the risk of a person who's engaging with an AI thinking it's a real person? Is that basically?
Yeah, that's a good one. I don't have an answer for that. I mean, I think we should tell people. I think when we have, because sometimes I'll go on the airport website and I'll start talking, and it doesn't say I'm an AI, and I think I'm talking to a person. Then pretty soon I realize, no, we're going in circles here. Can I talk to an actual human? I think we should tell people. That would be my vote. Yeah, but if do you have ideas?
Yeah, so we're kind of experimenting a little bit with how you have to, how you make the interface, how engaging you make it. For example, now we have something where people are really talking into a microphone and get an answer back, and people have different voices, different voices are talking back, and notice that is too much. As although people know that they're talking to an AI, they kind of forget about it while engaging. So I think there's many things that you can do in order to make it more maybe robotic or not so engaging. Please.
We have to give the AI a synthetic sounding voice.
Maybe. Yeah, I don't know.
I kind of like that. Yeah.
Okay, maybe last question for me. No, you're okay? Okay, last question.
I'm Ingeborg from the Netherlands, and I'm wondering, what's your opinion about where this is going? Because I really love the predictive part of AI, because I can ask questions nobody knows about, and I get a little bit of answers that I really like, and I know it's not the future, but we love to see somewhat things are coming to us. What do you think?
So you're saying now that you've asked the AI this question, you're asking me the same question? Never felt competitive with AI before. I mean, I think it's hard to separate where I think it's going from where I would like to see it go, and maybe that makes sense because I think we're all here, in part because we want to shape what comes next. So I think there's an opportunity to do that, and as a researcher and advocate of human computation approaches, I think keeping humans in the loop as part of the governance system will help with that. I think a big question that comes up a lot is about labor, and so we had the Industrial Revolution, now it's the AI is taking over all the jobs, but it's changing the jobs. It's still, in my view, I mean, I just showed you 5 gaps, and that's not all the gaps, so it's kind of reevaluating what do humans bring to the table, and hopefully it actually makes our jobs more interesting. Get the AI, frankly, synthesizing a 20-page paper is a lot of work, but if AI can do that for me and I can grasp what I need to very quickly, I can do my job more easily. One of our lead software developer, Ravish, is here, and he was telling us today, oh yeah, I use AI all the time to do coding. And I'm thinking that's fantastic because you're going to be coding 3 times as fast now, and you can focus on the interesting parts of the coding and let the AI worry about all the details. So I think we just have to kind of, try to be adaptive and also try to use AI to help us be adaptive. If it's there, let's leverage it to keep us kind of steering where the future is headed. Thank you.
Okay, thank you again.